For the last decade, financial regulators faced an operational headache, writing lasting rules for a technology that changes its technical architecture every few months. That dynamic is exactly what the Reserve Bank of India addresses in their draft Guidance on Regulatory Principles for Model Risk Management 2026. The innovation of this document lies in what it chooses to ignore. The RBI entirely abandons the attempt to nail down a static technical definition of artificial intelligence or technology. Instead, the regulator focuses on the application. They move away from inspecting the specific coding language or processing power of a tool, choosing instead to regulate the broad, functional category of models. By shifting the regulatory target to operational function, the RBI completely alters the compliance footprint for every single regulated entity in the market. There is a pervasive operational myth in financial compliance, the assumption that advanced machine learning requires strict governance, while standard legacy IT software does not. Take a look at this structural comparison. On the left, a complex neural network. On the right, a standard spreadsheet matrix. Under the GRP-MRM framework, the RBI places both systems into the exact same regulatory bucket. They trigger identical compliance protocols. The regulator explicitly groups the hazards arising from these tools under model risk, citing direct links to inaccurate outcomes, flawed decisions, and hard financial losses. The collateral damage of those initial failures is vast, extending from severe operational disruptions and compliance violations to systemic impacts on consumers and the broader financial system. A misconfigured spreadsheet formula can execute a flawed lending decision just as efficiently as a hallucinating AI. Believing your institution is immune to strict governance because you rely on basic legacy tools is a dangerous operational myth. This diagram outlines the RBI's first principles approach, stripping down what mathematically constitutes a regulated model into a strict three-part pipeline. The first component is the input. The system must ingest raw data alongside theoretical, empirical, or judgment-based assumptions. Next is processing logic. The system analyzes those inputs using statistical, mathematical, economic, or financial techniques. Notice this critical detail. The RBI explicitly categorizes the advanced cognitive techniques of AI and machine learning in the exact same processing bucket as standard statistics and math. Finally, the system produces an output result. Those results trigger regulation the moment they are utilized in active business operations and institutional decision-making. Under this pipeline, the mathematical complexity of the processing node is entirely irrelevant. The existence of an operational output is what demands compliance. The draft guidance provides a specific illustration to ground this theory in daily operations, a spreadsheet-based loan pricing calculator deployed by a regulated entity. First, the inputs are logged: borrower type, loan tenor, credit score, and collateral value. The tool applies its processing logic by running all those inputs through interest rate grids, risk-weighted spreads, and margin formulas. The calculation yields a critical output, the final lending rate. A basic mathematical tool crosses the threshold into systemic model risk the precise moment that rate dictates the actual credit terms offered to a customer. The core regulatory philosophy here is straightforward. The RBI evaluates the operational intent of the software, not the coding language it was built on. The framework relies on material impact. Any algorithm, analytics interface, or decision-based rule qualifies if it dictates how business processes are executed. The ultimate regulatory trigger is the use of a tool to automate decisions and bypass manual human intervention. That tool is subject to these rules, irrespective of whether the regulated entity formally recognizes it as a model internally. Any intent to automate a business decision inherently carries a severe systemic risk, placing it squarely within the regulator's crosshairs. With the threshold defined, institutions must turn their attention to operationalizing these principles by 2026. The broad definition captures models developed entirely internally by the institution's own engineering teams, but the scope equally captures models sourced entirely from external third-party vendors. To manage this scope, the GRP-MRM lays out a structural map spanning 6 distinct chapters. The compliance requirement begins with preliminary governance in chapters I and II. The mandate moves through the core operational phases: rigorous model risk tracking and continuous lifecycle management detailed in chapters 3 and 4. Finally, chapters 5 and 6 establish the rules for specific models and other regulatory provisions. This chapter structure forces regulated entities to track, document, and audit a model's risk from its initial sourcing all the way through its daily deployment. Zooming out, this guidance will force existing internal risk frameworks, such as the DGPSI AI, to recalibrate their definitions to match this broad functional baseline. AI governance is no longer an isolated technical task for the data science team. It is now the shared operational reality for compliance officers, risk managers, and every fintech engineer building automation tools. In this new landscape, the line separating basic software from AI is erased. If a system makes business decisions, it's subject to comprehensive model governance.